In the previous video, I told us what electrolysis is and defined other key terms you'll encounter in electrolysis. So now let's look at the various factors that affect the preferential discharge. When you hear the term preferential, it means selective. So let's look at the factors that will affect the preferential discharge of ions during electrolysis. Number one is position of ions in the electrochemical series. Two is concentration of ions in the electrolyte, and the third one is nature of electrodes. We're going to take this one after the other and look at how they actually lead to preferential discharge of ions during electrolysis. Just from the name preferential, it means that some ions are preferred to be discharged over others based on the factors I mentioned earlier. Now let's look at position of ions in the electrochemical series. So the electrochemical series is made up of potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold. This is the electrochemical series for the cations. Now for the anions, we have hydroxide ion, iodide ion, bromide ion, chloride ion, triazonitrate 5 ion, tetraoxosulfate 6 ion, and then the fluoride ion. Okay, so those ones made up the anions. Okay, now looking at this electrochemical series, the understanding of how these ions are positioned in the electrochemical series will actually help us understand which of these ions will be discharged during electrolysis. Now, if you still find it difficult to remember the ions in the electrochemical series, you can easily do that using this song. I taught my students this song and they easily use it to remember the ions, both in the electrochemical series of the cations and that of the anions. For the cations, we have the song potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, and gold. Let me take it again. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, and gold. Okay, so that's the song I taught my students that they easily use to remember the cations in the electrochemical series. Now for the anions, we have a mnemonic that I also taught them that they use to remember the anions. And the mnemonic goes as follows. Oh, I bought chaff, not superior fish. I take it again. Oh, I bought chaff, not superior fish. O is for hydroxide ion. I is for the iodide ion. But is for bromide ion. Chaff is the chloride ion. Not is the nitrate ion. Superior is the tetraoxosulfate 6 ion. Sorry, let me mention the IUPAC name of the nitrate ion. Not is triazonitrate 5 ion. Superior is tetraoxosulfate 6 ion, while fish is the fluoride ion. This mnemonic will actually help you remember the anions in the electrochemical series. Now, how does the position of ions in the electrochemical series affect the preferential discharge of ions? Those ions that comes before those ones below them, the ions that comes before the ones below them are actually more electropositive, that is for the cations, than those ones below them. So whenever an ion that is higher up in the electrochemical series together with the one that is lower in the electrochemical series are present in an electrolyte, the ion lower in the electrochemical series will actually be preferred to be discharged over that one at the higher part of the electrochemical series. This is because lesser energy is required to discharge the ion that is lower in the electrochemical series than that is higher in the electrochemical series. Now, for instance, if we have zinc and copper in an electrolyte, it will actually require lesser energy to discharge copper over zinc. Therefore, copper will be preferentially discharged over zinc. Okay, I hope you are getting this. This explanation I just gave is for the cations. Now for the anions, those ones are the upper parts of the electrochemical series, is actually less electronegative than the ones below them. This means that the hydroxide ion is less electronegative than the chloride ion or even the fluoride ion or even the sulfate ion. Okay, so for instance, if the hydroxide ion is in the same electrolyte with a sulfate ion, hydroxide ion will be preferentially discharged over the sulfate ion because lesser energy is actually required to discharge the hydroxide ion over the sulfate ion. I will actually not want this video to be too long. I will return back shortly to explain the other two factors, that is concentration of ions in the electrolyte and the nature of electrodes. Stay tuned for the next explanation on these factors. Thank you.